Welcome back to the Deep Dive. Today we're plunging into a claim that sounds almost too wild to be true. The idea that psilocybin,
Mhm.
the compound in magic mushrooms,
Mhm.
can essentially obliterate your unique brain neural fingerprint.
Yeah, I mean, your brain's identity wiped out. That is a dramatic thought.
It really is.
And it's one that stems from some fascinating, really recent neuroscience.
Exactly. So for this deep dive, we've been, immersed in the research. We have some key studies, including a significant one published just this year in Nature,
Hmm.
along with detailed analyses that really get into the weeds of what's happening in the brain.
Right.
So our mission today is to kind of get past those sensational headlines and really understand the science. What is a neural fingerprint? What did these studies actually show?
And, what does it all mean? For our understanding of brain identity, sure, but maybe more importantly for mental health and consciousness.
Yeah, precisely. We're going to look closely at the data, the scanning methods,
Hmm.
and try to make sense of what happens to the brain signature, during and after the psilocybin experience.
Okay, so maybe let's start by unpacking this whole idea of a neural fingerprint. What does that even mean in neuroscience?
Good question. Lay it out for us.
Right. It's actually a pretty cool concept.
Yeah.
In essence, your neural fingerprint refers to the unique, stable pattern of brain activity that's
Oh.
specific enough to identify you as an individual. The main way researchers look at this is through functional connectivity, basically, how different areas of your brain synchronize their activity over time.
Okay, so like a personalized communication map for your brain.
Precisely. Think of it as the specific way your brain networks tend to talk to each other. And it's incredibly robust.
Robust how?
Well, using techniques like fMRI, functional magnetic resonance imaging studies, have shown these patterns are so distinctive and stable within one person, but different between people, that you can identify an individual just from their brain scan activity with astonishing accuracy. Yeah, like often over 99.5% correct, even from just a minute or two of data from a resting state scan.
That's incredible.
It really is. It's a highly reliable sort of personal identifier for your brain's functional organization.
So my brain has its own unique, stable signature, like a fingerprint.
It does. And it's worth just quickly clarifying, this is different from that controversial forensic technique sometimes called brain fingerprinting.
Right, the one that tries to detect specific memories.
Exactly. That's about electrical signals and specific knowledge. What we're talking about here is the overall pattern of functional connections. And the claim is that this pattern temporarily becomes less distinguishable, less unique under psilocybin.
Got it. So the claim isn't that it detects what you know, but that the way your brain is connected, its signature pattern, gets temporarily blurred.
Right. The central claim from the source material is that psilocybin makes this highly individual, stable signature, well, less identifiable, maybe even temporarily disappear.
Okay, so the strong words used were obliterated or wiped out.
Yeah, those are the strong words. The idea is that during the psychedelic experience, this unique neural fingerprint gets profoundly disrupted. It makes it much harder to tell one person's brain scan activity from another's during that time.
And you mentioned the main study driving this discussion is really recent, from
Yep.
Nature.
Yes, the key paper that really propelled this specific idea is by Siegel and colleagues, published in Nature in July 2024. And it was a remarkably intensive study, which is, part of what makes it so compelling.
Intensive how? What did they actually do? What do the methods look like?
Well, they worked with 7 healthy adult participants initially, though the main analysis used data from 6 after 1 had to be excluded. But what really stands out is the sheer volume of imaging they did.
Okay.
Each participant underwent 18 fMRI scanning sessions over several weeks.
18 sessions per person.
18, yeah. They were scanned before, during, and after receiving a 25 milligram dose of psilocybin, that's, a standard high dose, or a control substance, methylphenidate.
Which is like Ritalin, right? A stimulant, but not psychedelic.
Exactly. So they had a non-psychedelic active control. One source called it a marathon of imaging. And I mean, that's really what it was. This allowed them to look at individual brain dynamics with incredible detail, using a technique sometimes called precision functional mapping.
18 sessions. That's some serious dedication to data.
Yeah.
So what did this marathon reveal? What happens during the acute psilocybin experience?
So during those few hours when the psilocybin was active, the study found what they described as massive disruption of functional connectivity.
There was massive disruption.
Yeah, the normal synchronized patterns across different brain regions were just profoundly altered. And the scale of these changes was huge. The changes in connectivity patterns were more than 3.5 times greater than the natural day-to-day variability they saw at baseline.
Okay, so this wasn't just subtle noise or a small shift. This is a fundamental shakeup of the brain's usual activity.
Absolutely. A widespread breakdown of the brain's usual choreography, you could say. And this disruption, according to the researchers, caused the individual fingerprint to dissolve.
Dissolve. Wow.
Yeah, and the descriptions in the source material are quite evocative. They said brains looked more alike under psilocybin.
More alike.
Yeah, almost like a crowd losing individual faces in a storm. The idea is that this highly personal neural identity tag was temporarily obscured, maybe even wiped out. Different brains seemed to converge towards a state that was more similar to each other, at least in terms of these broad connectivity patterns, than they were to their own typical baseline state.
That image of the crowd losing faces, that's powerful. It really captures that feeling of individual identity kind of disappearing at a neural level.
Mm-hmm.
And you mentioned earlier this might link to the subjective experience, like losing your sense of self.
Exactly. What's fascinating here is how well this neuroscientific finding seems to align with subjective reports. You know, that feeling of ego dissolution or losing the boundaries of the self. That's a hallmark of strong psychedelic trips. So this temporary wiping out of the brain's individual signature, it provides a potential neurobiological basis for that exact experience. If your brain's unique identifier dissolves, maybe that's partly why you feel less like a separate, distinct self during that time.
That makes a lot of sense. And speaking of the self, the sources really hone in on one particular brain network, the default mode network, or DMN. Can you remind us what the DMN usually does?
Sure. The DMN is a really critical network involved in internal processes. It's highly active when your mind is wandering, when you're reflecting on yourself, retrieving memories, thinking about the past or future.
Kind of the brain's introspective engine, or maybe the seat of the inner narrator.
Yeah, that's a good way to put it. It's often considered central to constructing and maintaining our continuous sense of self, that inner story that defines who we feel we are.
Okay, and how does psilocybin impact this network specifically?
Well, under psilocybin, the DMN shows the most intense desynchronization effects compared to other brain networks.
The most intense.
Yes. Its core regions, like the posterior cingulate cortex, which is often linked to autobiographical memory and our personal narrative, and the medial prefrontal cortex, which is deeply involved in thinking about oneself, self-reflection, our perspective. These regions normally work really closely together. But under psilocybin, they fall dramatically out of sync. One source described it as the DMN's coherence collapsing, undergoing radical desynchronization. Its usual tight integration just dissolves.
So the very network most associated with me and my personal story gets fragmented, disorganized?
Precisely. And the level of this DMN disruption is strikingly correlated with the subjective experience people report.
How so?
The more the DMN desynchronizes, the stronger the mystical type experiences participants report. Things like oceanic boundlessness.
Which is that feeling of dissolving boundaries, right?
Yeah.
Feeling connected to everything.
Exactly. That profound sense of unity dissolving the boundary between oneself and the world. And the correlation they found in the nature study data was remarkably high, an R-squared of 0.81.
0.81. That's huge in brain research.
It's incredibly high. It means over 80% of variance in how intense that mystical experience felt could be predicted just by looking at how much the DMN desynchronized. It suggests a really powerful link. The breakdown of this self-centric network provides a pretty solid neurobiological explanation for that feeling of ego dissolution and unity.
It's not just a correlation. It's a really strong statistical relationship.
Yeah.
Okay, so alongside this breakdown of usual patterns, the sources also mention increased brain entropy. That sounds chaotic. What does that mean here?
It does sound like chaos, doesn't it?
Yeah.
But in neuroscience, entropy or signal diversity isn't just random noise. It often refers to a higher degree of complexity and unpredictability in neural activity patterns.
Okay.
Psilocybin increases measures like Lempel-Ziff complexity, which is one way to quantify the signal diversity. Essentially, the brain moves towards a higher entropy state. This aligns with the entropic brain hypothesis.
Right, I've heard of that.
Which suggests this state is linked to more unconstrained, more flexible cognition.
So it's not just less ordered, it's maybe more complex and unpredictable in its patterns.
Yes, perhaps. At the network level, it seems to mean that brain networks that are usually quite segregated and specialized start communicating in novel ways across the whole brain. At the same time, their internal coherence within a single network breaks down.
So less distinct modules, more interconnected web.
Exactly. The brain organization becomes less modular, more like a flexible, globally interconnected system. It's described as a complex reorganization process, potentially making the brain more adaptable and malleable, at least temporarily.
It sounds like this acute state of disruption and increased complexity could be a precursor to change. But let's circle back to that word obliteration. It sounds so permanent. Is this neural fingerprint truly gone forever?
Yeah, that's a really crucial point, and this is where we need some nuance, as highlighted in some of the sources, especially those looking at science versus sensationalism. Obliterated is definitely an exaggeration if you interpret it as permanent destruction. The research is clear. This is a temporary masking or disruption of the fingerprint. The brain patterns become distinguishable again after the acute effects wear off.
So more like blurring the image or scrambling the signal for a few hours.
Exactly. And there's actually an interesting wrinkle here mentioned in the sources, particularly a survey note that looked at different analyses. While the Nature study found brains look more similar to each other during the trip using standard fingerprinting methods, another study by Amico and colleagues in network neuroscience earlier in 2024 found that functional connectomes actually became more idiosyncratic under psilocybin.
More idiosyncratic, meaning more unique.
Yeah, more unique, at least in the acute phase.
No, wait, that sounds like a direct contradiction. How can brains look more alike and more unique at the same time?
It does sound contradictory, right? But it probably isn't a direct contradiction. It likely highlights the complexity and, importantly, how we analyze the data. The sources suggest it reflects different analysis methods, or maybe focusing on different aspects of the brain's dynamics. It's possible, for instance, that Siegel's analysis focused on the overall pattern similarity across individuals during that intense psychedelic state. Maybe the sheer scale of desynchronization makes everyone look sort of generically chaotic in similar broad ways when viewed from a distance, whereas Amico's method might have captured the unique ways each individual's brain navigates that chaotic state at a finer, more complex level, making their specific style of disruption still idiosyncratic.
Ah, okay. Like everyone's jumping into a mosh pit. It's chaotic, but each person still has their own unique way of moving within that chaos.
That's a great analogy, sort of fingerprints in chaos, as one description put it. The way your brain falls apart might still be unique to you.
That makes more sense. Different ways of measuring or looking at the data, but the main takeaway is this loss of distinguishability is temporary and reversible.
Absolutely. The loss of distinguishability happens during the acute phase, lasting for hours. It's also partial. We talked about the DMN being most affected, but not all networks equally. And critically, yes, it's reversible. Most connectivity patterns start returning to baseline within days, with full normalization typically occurring within, say, 6 to 12 months, according to the sources.
Okay, so the intense acute effects wear off, the fingerprint comes back, but what happens after the trip is over? Do any changes stick around?
Yes. And this is where the idea of the neurological reset becomes really interesting, and the Nature study had some compelling evidence here. While those dramatic acute effects fade, some specific changes do appear to persist for days to weeks afterward.
Oh, really? What kind of changes?
The Siegel study found a very specific persistent change, reduced connectivity between the anterior hippocampus and both the default mode network and the broader cortex.
Okay, the hippocampus, that's memory,
yeah,
right? And the DMN is self-reflection, so the connection between memory and self.
Exactly. The hippocampus is critical for forming new memories and integrating them. Its interactions with the DMN are thought to be crucial for weaving those memories into our sense of self, our personal narrative.
And this reduced connectivity, how long did that specific change last?
Remarkably, in their study, this specific reduction in connectivity persisted for exactly 3 weeks post-administration.
Exactly 3 weeks, not about 3 weeks.
The paper specifies 3 weeks. It's a very precise duration reported for a specific circuit modulation, and it stands out because most other widespread connectivity changes normalize much faster, usually within days. So this is highlighted as a strong candidate for explaining the neurobiological underpinnings of potential proplasticity effects, basically making the brain more adaptable and open to new learning or change for a period.
3 weeks specifically.
Yeah.
That's fascinatingly precise.
It really is. While most brain activity patterns normalize quickly, this lingering change in the hippocampal DMN connection for a defined period, it points towards maybe a sustained state of enhanced malleability. And this aligns well with findings from animal studies showing structural changes, like the growth of dendritic
The
spines.
little connections between brain cells.
Right, the tiny projections that form synapses.
Hmm.
Animal studies show these can grow and persist for weeks to months after a single psychedelic dose.
So it's not just fleeting activity changes during the trip. There might be a window for actual structural rewiring or strengthening afterward.
Exactly. That's the basis for this idea of a neurological reset. It's not like wiping the hard drive clean, though. It's more like shaking a snow globe, an analogy used in the sources. The established, sometimes rigid patterns get disrupted, and as things settle back down, they have the opportunity to settle in new, potentially different ways. This state of enhanced flexibility is hypothesized to be a period where the brain is more receptive to laying down new, perhaps healthier connections, and where individuals might be more able to revise deeply ingrained, sometimes maladaptive beliefs.
And that links to some theories about how psychedelics work therapeutically.
Yes, this is where frameworks like the Rebus model, relaxed beliefs under psychedelics and Rebus relaxed beliefs, and the self come in. They propose that psychedelics work partly by relaxing the grip of our strongly held beliefs, especially those related to ourselves, making them temporarily more malleable and open to revision.
This really seems to get to the heart of the therapeutic potential, Ham. If conditions like depression or anxiety involve rigid, often negative thought patterns, and maybe corresponding rigid brain patterns, then disrupting those patterns and creating flexibility sounds like it could be really helpful.
That's a core hypothesis driving a lot of the current clinical research. By disrupting these rigid, stuck patterns, particularly those involving the DMN in conditions like depression or OCD, and creating this period of enhanced flexibility and plasticity, psilocybin seems to open up a window of opportunity.
A window of opportunity.
Yeah. During this time, the brain is potentially more malleable. It might be easier for individuals, especially with therapeutic support, to process difficult emotions, gain new perspectives, and maybe lay down new, more adaptive neural pathways and beliefs.
And the clinical trials are showing some promising results.
They are, yes. The sources discuss how clinical trials for conditions like depression, anxiety, and addiction are showing rapid and sometimes sustained relief. For instance, one trial mentioned had a significantly higher remission rate for depression with just 1 or 2 doses of psilocybin compared to a daily antidepressant over several weeks.
That's pretty remarkable. And does this often link back to that subjective experience we talked about?
Yeah.
The ego dissolution?
Critically so. The sources really emphasize the strong correlation between the intensity and nature of the subjective experience, particularly those feelings of ego dissolution or unitive mystical experiences, and the therapeutic outcomes later on.
Okay.
This raises a major question that the research is grappling with. Is the subjective trip itself necessary for the therapeutic effect?
Ah, right. Is it just the chemical action on the brain creating plasticity, or is the conscious experience of that altered state a crucial part of the process?
Exactly. It's a huge question, especially for developing treatments,
Because
it poses a challenge for efforts to develop non-hallucinogenic psychedelic-like compounds. If the subjective experience and its link to disrupting patterns like those in the DMN is essential, then removing the trip might inadvertently remove the core therapeutic mechanism, or at least a major part of it.
that's a really critical point. Now, while all this sounds incredibly exciting, it's important we maintain some cautious optimism,
Yeah.
right? What are the limitations here?
Absolutely. And the sources are very clear about the current limitations. For one, many of these foundational brain studies, including that key Nature paper, use very small sample sizes.
Like the 6 or 7 participants you mentioned.
Right. Another large trial mentioned involved 46 participants in the psilocybin group. These numbers are still relatively small when trying to generalize findings to broader populations.
Small numbers mean we need more data before drawing really firm conclusions.
Definitely. There are also significant challenges with placebo control in psychedelic trials.
Because it's kind of obvious if you got the real thing.
Pretty much. The effects of a high dose are so profound that participants almost always know if they received the active compound, which makes true blinding very difficult.
Okay. What else?
Long-term follow-up data, especially beyond, say, 6 or 12 months, is still quite limited. We need more time to see how durable these effects really are. And much of the detailed brain imaging has been done primarily in healthy volunteers, not necessarily people with active clinical conditions, although clinical trials are obviously expanding rapidly in patient populations.
And context. You mentioned that seems crucial.
Hugely important. The effectiveness and safety seem highly dependent on the person's mindset, expectations, preparation, and setting, the physical and interpersonal environment where the experience takes place.
Right.
One source even mentioned that simply having participants perform a basic perceptual task during the trip actually reduced the level of desynchronization observed in the brain.
Really? Just doing a task changed the brain effect.
Yeah, it suggests that even focused attention can modulate these profound effects, which really underscores the critical need for professional guidance, therapeutic support, and preparation, which importantly was provided to the volunteers in these studies to help navigate the experience safely and constructively.
It's clearly not just about the substance itself. It's the whole container, the whole process and environment around it.
Exactly. And there are still key unanswered questions driving the field forward.
Like the necessity of the trip.
Yes. Is the subjective trip truly necessary for the enduring therapeutic effects? What are the very long-term effects, maybe years down the line? And how exactly can this window of enhanced plasticity, that 3-week period of altered connectivity, perhaps how can that be best leveraged with integrated therapy and support after the acute experience to really maximize positive outcomes?
So for someone listening, trying to make sense of all this,
Yeah.
how might they responsibly leverage these insights, if at all?
Well, I think the main takeaway from the sources isn't really an endorsement of unsupervised use. It's more about understanding the potential mechanisms and the profound importance of context.
Okay.
Leveraging these insights responsibly means recognizing how crucial set and setting are, having a clear intention if engaging in therapeutic or exploratory work, and critically engaging in integration post-trip.
Integration. Can you say a bit more about what that involves?
Sure. Integration is really the active process, usually done in the days and weeks after the experience, often with a therapist or guide, but also through personal reflection, journaling, maybe certain practices, to process the insights, the emotions, the changes experienced during the psychedelic state. The idea is to work with that material, ideally during that hypothesized window of increased brain malleability, to help solidify new perspectives, healthier behaviors, and maybe even new neural pathways.
Making sense of it and weaving it into your life afterwards.
Exactly. It's about making meaning and facilitating lasting change.
And is this anything like microdosing? People hear a lot about that too.
Good question. The sources clearly distinguish between macrodosing, the kind of full doses used in these studies that cause the profound effects, and the obliteration of the fingerprint we discussed, and microdosing, which involves taking subperceptual doses, amounts so small you don't consciously feel psychedelic effects. Microdosing is very unlikely to cause the same massive disruption or obliterate the neural fingerprint in the way a high dose does. Its effects, if any, are much subtler. And frankly, the scientific evidence for its benefits is currently less robust and much more mixed compared to the data emerging from macrodosing trials in controlled clinical settings.
Okay, so different scales, likely different mechanisms and effects. And for people who aren't interested in psychedelics at all, are there any takeaways here just about brain plasticity in general?
Absolutely. I think one takeaway is just how dynamic the brain is, but also the sources sometimes mention that practices like deep meditation, certain types of breath work, or even intense creative flow states can also induce shifts in brain states, including things like temporary reductions in DMN activity, which is somewhat related.
So other ways to potentially shift brain patterns.
Yes, though generally less intense shifts, they likely won't obliterate your neural fingerprint in the same dramatic way. But they do point to the brain's inherent capacity for dynamic change and accessing states of altered connectivity and perception just through different non-pharmacological means.
Interesting. Okay, so to try and sum all this up, psilocybin doesn't permanently destroy your brain's unique signature.
That's correct. It doesn't destroy it.
Not at all.
Instead, it temporarily and profoundly scrambles it, desynchronizes networks, especially that default mode network, making brain scans less distinguishable during the acute experience. This dramatic disruption seems to open up a temporary window of enhanced flexibility and malleability, a kind of neurological reset that appears to last for weeks, highlighted by that specific 3-week finding about reduced hippocampal DMN connectivity.
Right.
And this period of plasticity is hypothesized to be key to its potential promise in treating conditions characterized by rigid brain function and thought patterns. Precisely. It's a temporary disruption that seems to allow for a longer-lasting potential for change and healing, especially when combined with the right support.
It's a really fascinating picture of the brain.
It really is. This research is challenging our ideas about how fixed the brain is. It shows the human brain is far more dynamic, far more capable of profound temporary reorganization than we often imagine. And it leaves us, I think, with a really interesting, perhaps even provocative question to ponder.
Go on.
Well, if temporarily losing your sense of a fixed self and it's ingrained, sometimes rigid patterns can actually facilitate healing and allow new connections to form. What does that tell us about the fundamental nature of identity and consciousness itself? Is that typical stable sense of self always the most adaptive state? Or could temporary dissolution, that temporary scrambling of the fingerprint, actually be key sometimes to resetting growth and well-being?
That is a powerful thought to consider. Thank you for joining us on this deep dive into psilocybin, neural fingerprints, and the dynamic brain.
Thank you. It was fascinating to discuss.
And thank you for listening. We hope this dive has helped clarify the science behind some of these dramatic claims and given you a richer understanding of this really fascinating area of research.